Hey everybody, welcome to the final installment of Dividing Decimals, Part 3, The Journey's End. So this will be the last video slide presentation we have on dividing decimals. So yay! Anyway, just a quick review. What we've talked about so far in terms of strategies, we've got option 1, the common denominator strategy, where you rewrite the decimal division as a fraction division problem with common denominators, which allows you just to divide the numerator. Option 2 is writing it as a single fraction, writing the decimal division as a single fraction, but then multiplying by both numerator and denominator by a power of 10 to remove the decimals and just ended up with a whole number long division problem. And option 3, which is really just option 2 in disguise, is to do the same thing, but just instead of writing as a fraction, writing it actually out as a long division. So if we've got 15.6 divided by 3.12, same thing. We're going to multiply both the numerator and denominator, or the dividend and the divisor, by a power of 10 to remove the decimal point. So in this particular problem, we would multiply both by 100 and be left with 1560 divided by 312. And we can just go ahead and do the long division. And as I've mentioned a couple of times now, this is all well and good, and these are great strategies when the answer comes out to a nice happy whole number. But in the real world, that very rarely happens, because most of the numbers in the world are not whole happy numbers, right? So we've got examples here that we're going to look at today of two whole number divisions that don't work out nicely. As you can see from starting that 738 divided by 24, you can end up with 30, but then you have a remainder of 18. So what do we do with that remainder of 18 if we're trying to get it into a decimal, okay? And then another problem, 76 divided by 95. We're already starting out with an issue in that 95 is smaller than 76. How many 95s can fit into 76? Well, not any, right? Well, yes, a part of a 95 can fit into 76, but we've got to figure out what part of 95 can fit into 76. Or if you think about it as 76 being broken up into 95 groups, 76 wholes being broken into 95 groups, only part of those 76 wholes, of each of those 76 wholes, are going to be able to be used in each of the 95 groups, because you don't have a full 95 wholes to split into 95 groups. And if you did them on your calculator, you would find that 738 divided by 24 is 30.75, and 76 divided by 95 is 0.8. The question is, how do we know that without using a calculator? And yes, I know, for the rest of your lives and most of the rest of the world, when you hit these problems, you're just going to grab a calculator and do them. But what if there's an electromagnetic pulse and the entire electronic system of the world crashes and collapses and you have to do long division with decimals? What are you going to do then, right? So we need to know how to work these problems through without the aid of any electronic device. So let's look at 738 divided by 24, and these start out just like your regular long division problems, and they actually continue just like your regular long division problems. There's just some things we need to think about. Okay, what does this actually mean? How do I continue this problem when it starts to go into decimals? So let's work this through together. And yes, you should be taking notes. This should be going down in your notebook. So 738 divided by 24, right? So we've got 7 hundreds, 3 tens, and 8 ones. Now, if I've got 7 groups of 100, I can't split those 7 groups of 100 evenly between 24 groups without changing them into groups of 10, because I just don't have enough, right? So I can't split the 7 groups into 24, the 7 groups of 100 into 24. So I put an X, or you can put a 0, either way, right? So then, well, I've got 7 100s, but if I change those out for tens, I now have 70 tens plus the 3 tens that I already had. So I have 73 tens, which I can change out, right? Which I can split into 24 groups. And if you think about how many would go into each group, we can fit about 3 into the 73 groups. Sorry, we can 3 into the 24 groups, and that would give us, we would use up a total of 72. So we've used up 72, which means we have one group of 10 left over. I can't do anything with that group of 10 unless I split it into ones, right? So I bring down my 8. So I have one group of 10, which is 10 ones plus the 8 ones I already have. Now I have 18 ones, and I still don't have enough ones to split into 24 groups. So for this particular part of the problem, we have to say up in our answer that I can't put any of those ones in the 24 groups. So in the ones place in my answer, I have to put a 0 because I can't put any of those ones in into 24 groups because I don't have enough of them to do that. Okay, so we still just continue on. 0 times 24 is 0. I haven't used any ones, right? Because I didn't have enough to put into 24 groups unless I change them again into something smaller, right? So I've got 18 ones. I didn't use any of them, so I still have 18 ones, okay? But so now we're still stuck. We've got 30 and a remainder of 18. But we just continue on doing exactly what we've been doing, which is changing things out for the next smallest place value, right? We change thousands into hundreds, we change hundreds into tens, we change tens into ones. The next smallest place value is tenths, right? So if I've got 18 ones, I've got to change that to tenths, right? In order to do that, I've got to indicate what do I already have in my tenths place. Well, in this particular problem, I don't have anything in my tenths place, so I can just put a 0.0 up in my 738, and that just indicates that I have 738 wholes and no tenths to start with, right? If it was 738.5, I would have had 5 tenths. So if we change, we can now bring down that 0, just like we always have, and say, okay, well, I've got 18 ones, which is equivalent to 180 tenths. Now I can split 180 tenths into 24 equal groups, right? I've got enough of them to if you imagine holding 180 tenths in your hand, right, then I've got enough of them to start distributing them to 24 groups. So one important thing you need to do after you add that 0.0 in your dividend, you need to also put it in your answer, right? Because so far we have said if I split 738 things into 24 groups, 30 wholes will go in each group. And now I'm moving into the tenths place, so I need to indicate that by putting the decimal in my answer. So we've changed 18 ones for 180 tenths, and we can figure out, okay, how many, if I'm splitting those 180 tenths into 24 groups, how many can I fit in each group? And I can fit about 7. 7 times 25 would be 175, so 7 times 24 seems a pretty good option. That would give you 168 things. We keep going just like we would normally do, and now we have 12 left over. So we had 180 tenths, we put 168 tenths into groups, and I've got 12 tenths left over. I still have stuff left over. So what do? Well, just like we've always done before, I've got to change them for the next smallest thing, which would be hundredths, right? So in order to do that, I'm going to add an extra 0 up in my hundredths place to show that I don't have any hundredths to start with. I just have 0. And I'm going to bring that 0 down. So I've changed my 12 tenths for 120 hundredths. It's the same thing. 12 tenths and 120 hundredths, that's the same. Those are equivalent fractions. So we're allowed to do that because it's the same thing. And now 120 hundredths, I'm going to split those into 24 groups, and I can put 5 into each group. So voila, I subtract, and I am done, right? I've gotten to 0. I don't have anything left that I need to split out into groups, so I am done with the problem. Okay, yay. So for each problem below, you're going to adapt the division strategy on the previous page to find the quotient. So we're going to do what we just did to find the quotient. And always estimate. It's always a good idea to estimate to check your answer. Okay. So on the next slide, I want you to do the problem with me as I do it on the screen. So I'll give you little chances to work it through. So we've got 765 divided by 25. That was problem A from the previous slide. You're going to do problems B through D in a minute on your own. Okay, so first thing you've got to ask yourself, right? So you've got 7 100s, 6 10s, and 5 1s. Can 7 100s be split into 25 groups without changing them into tens. So what do you think you should put in your notebook? Put it there now. Can they be split? No, they can't, right? So what do we have to do? We have 7 100s, and we want to change those for tens. So that gives us 70 tens plus the 6 tens that we already had. So now we have 76 tens, or 76 groups of 10, which is 760. So can I split those 76 tens into 25 groups? Yes, I can, because I've got enough to go in each group. So right now, try to figure out how many you think of 76. If you've got 76 things, splitting them into 25 groups, how many would go in each group? 76 is awfully close to 75, which is divisible by 25. So this should be a pretty easy one. And we know that 3 things will go in each group. So if we've got 76 tens and splitting them into groups in 25, 3 will go in each group. We've used up a total of 75. How many are we going to have left over? Put that down now. And we should have 110 left over. Right, so I can't do anything with that 110 until I change it for some ones. So I'm going to change the one group of 10 is 10 ones plus the 5 ones I already have. Now I have 15 ones. But what's the problem, right? Can I split those 15 ones into 25 groups? Yes, no, think about it. No, I can't, right? So I have to indicate in my answer that I can't put any of those ones in those 25 groups. So I put a 0 in the ones place in my answer. So 0 times 25 is 0, right? We haven't used any. We still have, how many do we still have left? Show it in your notebook right now. How many do we still have left? We still have 15 left. And so now I've found out, okay, well, I can put 30 in each group, but I still have 15 left, and my problem's not done, right? I have to keep going, just like we did on the last one. So this is the point. I've got 15 ones. I need to change it for the next smallest place value, which is tenths. Okay, so I have to indicate up in my problem that I don't have any tenths to start with, right? I'm just adding 0.0. That doesn't change the number at all, right? It's just saying I don't have any tenths, but now I can change my 15 ones for 150 tenths, which I can split into groups, right? Into 25 groups quite nicely, actually. So you also need to remember that up in your answer, right, we've said that 30 wholes can go in each group, but now we have to indicate that now we're moving into tenths. So we have to split that, we have to put that decimal point in to show that we're changing between whole numbers and decimals. So your decimal point needs to go up in your answer as well. And that's why it's really important in long division to be very neat and precise, because if you start moving things around or not careful, you'll get your decimal point in the wrong place. So if I've got 150 tenths and I'm splitting them into 25 groups, how many tenths can go in each group? 6, right? 150 divided by 25 is really a simple, straightforward to do because 150 is divisible by 25. So now I've showed that 30 wholes and 6 tenths can go in each of my 25 groups. 6 times 25 is 150, and I don't have any left over. So, more practice. So back to these problems. For problems B through D, I want you to try them in your notebook now. Pause the video and do the problems, and then these will be checked for homework. Right? I'm not going to go over each problem in the video because the video would go on forever. So pause them, do them in your notebook, and when you are done with those 3 problems, then continue the video to see another type of problem where this type of division comes into play. So pause now and do B through D, please. Okay, so another example of when this type of long division is important is when we have a dividend that is smaller than the divisor. So far, we've only been dealing with dividends that are bigger than our divisors. So what happens when we have something like 76 divided by 95? We don't have enough ones to start with to break into 95 groups because we only have 76 of them. So you have 7 tens, which we can't split into 95 groups, right? Because there's only 7 of them. And even if we change them for ones, right, we have 76 ones, which we also can't split into 95 groups. So this is just like what we were doing in the previous problems when we got to the point where we didn't have enough of whole numbers to split into groups. So what are we going to do, right? Well, same thing we were just doing, okay? Just in this case, you don't have any whole number as part of your answer. Your first digit is going to appear in a decimal place. So we have to change our 76 ones into tenths, just like we were just doing. Okay, so that will give 760 tenths. We'll add a 0 in the tenths place and put our decimal point in, just like we were doing in the previous problems. And then you need to also put your decimal point up in the answer to indicate that, okay, now we didn't have any whole numbers, but now we need to show, okay, how many tenths can we put in each group, how many hundredths, and so on. So you need to make sure that your decimal point is in your answer as well. So we have 760 tenths going into 95 groups. So we can split our 76 tenths into 95 groups because we have enough of them now. 95 is pretty close to 90, and 760 is pretty close to 720, and 9 and 72 go together. So I'm going to see, since 72 divided by 9 is 8, I'm going to see if 8 works. I'm going to estimate and see if 8 works. So 8 times 95, so 8 times 90 would be 720, 8 times 5 would be 40, so that would give me 760, and voila. I subtract, and I don't have anything left, and I'm done. So just like we were doing in those problems previously, it's just this time we're starting out, like I said, our first digit's going to appear in the decimal places, not in the whole number places. Okay, so last thing that you need to do in your notebooks for homework is to complete these 2 problems in your notebook, and you'll check them for next class. And again, these are 2 where your dividend is smaller than your divisor when you start. So if you need help, go back and just look at the slide that I just went over, or the problem that I just went over. Okay, finally, all graphics from this presentation are from Connected Mathematics Decimal Operations, section 3.5, published by Pearson Learning. Thank you. I'll see you guys soon. Bye.